Good morning. So glad you could join us for a quick discussion on some of the tools available in standard QAD to help you in today's changing world of demand and economics. Regrettably, there are certain forces afoot that seem destined to play havoc with our ability to foresee the future. In these times, we need a stable approval to supply chain planning. Our organizations need to be able to forecast and project our absolute best guess at the future. Business forecasting predicts future trends, outcomes, behaviors, and a guide to decision making. Businesses use forecasting to help make decisions about the direction of the company. The forecasting aims to predict the future, and by doing so, help people and companies allocate resources, make decisions on capital, staffing, advertising. Without business and forecasting, a business operates in the dark and may not be able to adjust itself to the right path to earning success. Today, we'd like to cover some of the following areas: just an introduction to forecasting, a little background, talk about simulation forecasting, how we forecast consumption, seasonality, our 32 soft loaders for forecasting, and the QA demand management. Forecasting is the process of using data and analysis to predict the future outcome, trends, and risks. It spans financial, operation, and strategic planning domains. Forecasting is not just a financial tool, it's a strategic imperative for growth, resilience, and agility. Businesses that invest in dynamic, data-driven forecast are better equipped to thrive in today's dynamic landscape. Forecasting has become essential for both businesses and governments to navigate a world marked by rapid technology change, volatile markets, and global uncertainties. Forecasting involves informed decision-making, risk management and crisis preparedness, risk management, resource allocation, dealing with volatility, looking at policies and investment decisions, and understanding market trends and behavior. As always, lots of concepts, acronyms, and words to learn and understand. Forecasting in manufacturing has progressed from early approaches, intuition-based guesses and manual spreadsheets, to more sophisticated approaches with statistical tools, to the rise of ERP systems in the 20 and 2010s, morphing into the modern era of advanced analytic and AI-powered systems with data-driven, collaborative, technology-enabled forecasting techniques. Each stage has brought greater accuracy, collaboration, and strategic importance, enabling manufacturers to anticipate demand. We need to work hard to keep up. There are several business considerations before settling on a forecasting system. We need to think about product life cycles. We'll talk about forecast consumption. How far should the MRP go out? Sales and revenue projections, market entry, spares, multiple sites. Forecasting hits just about every aspect of our operations. To be successful at forecasting, you must identify all sources of demand in your organization. All sources might include customer demands, spare parts, dates, quantities, sister divisions, lots of places to track for demand. All of these sources need to have processes and procedures in place to capture all demand, categorize it, aggregate it, and store it for analysis and computation. Before we get into the methods and technology of forecasting, there are several areas that need to be set up and configured to maximize the forecasting process, from 7.1.24 to 22.7 to the item master and planning configurations. Item, as with all things in MRP, start with the item master and how you configure all of the 83 some odd elements is going to have a great deal of effect on how accurate your database and your forecast is, from items to item data, item picking, shipping, inventory planning, cost, and in item planning, specific particular attention should be paid to the fields of master scheduling, planned orders, time fences, make-buy codes, lead times, and replenishment codes. Also, how well we define and categorize our customers, the source of our demand, the better we will forecast. Properly setting up elements is 2720.1, customer create, 2.1.1, customer data management, is essential for leveraging QAD's forecasting and simulation capabilities, enabling accurate planning and efficient supply chain. Best practices with regards to customers entail data completeness, regular audit of customer records, and a well-thought integration with the rest of ERP. After the 2720 customer create has been defined, 2.1.1 customer data maintenance, basically the old stuff from EV versions, needs to be input as to customer codes, sites and domain associations, customer types and statuses, consumption parameters, and customer specific planning data. We need sales orders to capture data. That will be then used as the basis of a forecast, so that we can therefore have to tell 7.1.24 sales order control to integrate with the sales analysis module. A word here: if you're going to have a usable, viable, consistent, and functioning forecast system, you need to use QAD to store the data. Do not use spreadsheets. You will also need to define customer consumption from sales order as to whether you forward or backward consume. In conjunction with the release of 2016, many financial and accounting parameters were moved to 36.9, accounting control area of QAD. Special attention should be paid to 36.9.6, sales order accounting control, as there are several fields that will affect your forecast data. The 7.17.25.2 build sales analysis function is designed to generate and update the detailed tables that undermine or underpin sales analysis reporting within the sales analysis module. This process is essential for ensuring data is used in sales analysis to create the most recent forecast. When utilizing 7.17.25.2, understanding the sales history patterns is essential for building accurate data models. Each pattern represents a distinct behavior in historical sales and requires specific modeling techniques. You typically have one or more patterns in your forecast population representing either trend, seasonal, horizontal, or cyclical data. One of the more useful tools in forecasting system is the 2.9 op address list type maintenance. With this list type, the system stores optional address codes. That address can have multiple list types that you can then manually assign additional list types for creating forecast groups, subgroups, or even item level forecasts. Forecast process is really fairly simple. Techniques may be more complex, but ultimately you define your objectives, you gather historical data, you analyze the data, select and apply a suitable forecast model, generate and interpret the forecast, compare the forecast with actual outcomes, and then repeat the process on a periodic basis. As forecast is really only a projection of demand, the primary characteristics of demand is either that it is dependent, therefore dependent on some other item, such as its parent, or it is independent, that is, it is demand at random, that is not tied to the demand for something else. We only forecast independent demand. Each occurrence of demand comes with several characteristics, such as each demand is small compared to the total. Demand is spread over time, therefore it is time dependent. And the variation is small compared to the average demand. There are specific forecasting and control techniques for each type of demand. And some parts have both types of demand. As mentioned, forecasting uses various models to predict future sales demand and other business metrics. Techniques range from very simple to complex statistical models. All need to be tailored to different business needs. In QAD, we use 22.7 forecast simulation menu to do this process. Forecast is done for many reasons, ranging from financial to sales to demand. Each can have its own method of arriving at a viable forecast. Choosing the right forecast type means the selection of a forecasting technique that depends on your organization's business goals, data availability, forecast horizon. Often businesses combine multiple forecast types and methods for accurate results. Regular review and adaptation needs to be done to improve forecast reliability. That is, you may change techniques over time. There are two basic methods in forecasting: quantitative methods, using historical data and statistical models, and qualitative methods, incorporating expert opinion, market analysis, when you're lacking statistical data. A third type, referred to as scenario planning, can be used to develop multiple future plans to test strategic scenarios. I'd refer you to project management and the master production schedule workbench. Probably the simplest forecasting method is what is called the naive method. This method uses the last observed value as a forecast for future periods. A derivation of this method is called the seasonal naive method, which uses the latest observed value for the same season or period as last year's, or the drift naive method, which projects values by extending a trend observed between the first and the last points. Basically, this is called the lazy man's forecast. Time series analysis examines historical data points collected over consistent time intervals. It allows for identification of patterns such as trends and seasonalities to forecast future values. It is the most widely used technique for sales revenue and demand. The moving average method calculates the average as a set of number of past periods to smooth out short-term fluctuations. This is used for short-term forecasting and to identify underlying trends. One can use simple or weighted average to give more important to more recent data. A more sophisticated moving average is what is referred to as exponential smoothing. This weight moving average is a formula that mathematically assigns exponentially decreasing weights to older data that gives more responsiveness of the new forecast to recent changes in historical data. It is an effective tool for forecasting data with no clear trend or seasonal pattern. As stated, exponential smoothing is a moving averaging technique. It is represented by the formula where the new forecast is equal to alpha times actual demand plus 1 minus alpha times the previous or the old forecast. It uses previous average and latest period and a single weighting factor. The weighting factor is referred to as a smoothing constant and is represented by the symbol alpha. These three pieces of information are all that is required to calculate the new moving average. Trend and seasonal patterns can be added to the basic exponential smoothing projections. The smoothing factor determines the relative weight of a historical average and the current demand on the new projection. The value of alpha must be greater than 0 and less than 1. Typically, values range from 0.1 2.5. Exponential smoothing in some form or another dates back to the work of the French mathematician Simon Poisson. Its application in forecasting was pioneered over a century later by Robert Brown in his publication Exponential Smoothing for Predicting Demand. Here's a quick example of a calculation of a forecast using exponential smoothing with two alpha factors, one of 0.1 and the other of 0.5. After working through the computations, you can see the difference between the 0.1 alpha and the 0.5 alpha. 0.5 makes the new forecast more reactive to the change. Here we can see that graphically displayed. The choice for alpha might apply to different items or groups depending on their age, where they sit in the production cycle, or other factors. Here we see the formula developed by Charles Holt and Peter Winter. The Holt-Winter formula introduces trend via the concept of adding a beta to the original exponential formula. The Holt-Winter's method is widely used for time series forecasting because it can model both trend and seasonality by incorporating the three components of level, trend, and seasonality, each with its own smoothing parameter. This method remains a foundational tool in forecasting and is applied across many industries today. Regression analysis is a statistical method used to examine quantity relationships between a dependent variable and one or more independent variable called predictors or explanatory variables or features. Simple regression is a forecast based on two variables, one independent, one dependent. Multiple linear regression imports multiple independent variables to predict outcomes, capturing one or more complex relationships. Regression analysis is useful for understanding how different factors influence business metrics. Causal models or causal models, also known as associative or explanatory models, that predict values of a variable by what nationally was defined by Poisson. Unlike pure time series modules, which represent solely historical data, causal models allow you to use cause and effect relationships, and they can include both regression and econometric models. They help understanding how external factors influence the forecast. Common qualitative forecasting techniques incorporate external or subjective models into forecasting. This includes executive opinion, Salesforce composite opinions, scenario planning, market research, Delphi surveys. These are valuable when historical data is limited or in rapidly changing markets like today. Here is a more exhaustive list of the various forecasting models and techniques. Some are simple, but some will require extensive study and setup and process to correctly utilize. The list continues, and as you can see, there are many, many tools or techniques that have been developed to create a projection of demand out across the horizon. Each holds its own pros and cons, and you get to decide which one you use. QAD has 7 predefined models for forecasting. Methods 01 through 06 are predefined. Methods 07 through 50 are reserved for QAD's use, and methods 51 through 99 are for user-defined forecasting methods. Method 00 indicates that the forecast detail record was not generated by the system or by some other mode such as sim loading. Double moving average, or method 2, is the simplest of the forecasting techniques. It computes moving average based on a 4-month period. However, it can lag behind trend effects. Double exponential smoothing, or method 3, is the most popular forecasting. Hark back to our discussion of exponential smoothing, and like double moving average, it includes a weighting factor. The linear exponential, method 4, is similar to exponential smoothing and incorporates a trend and seasonal factors using alpha and trend factors. It does require at least 2 years of history. Classical decomposition, or method 5, recognizes 3 underlying patterns: trend, seasonal, and cyclical. This also requires at least 2 years of history. Simple regression, method 6, sometimes called the least squares method, ensures that the forecast quantity is equally likely to be higher or lower than the quantity sold. This method is good for horizontal time series data. The best fit, or method 1, uses all the predefined methods and then selects results with the least mean absolute deviation. This method does not need prior knowledge of underlying patterns present in sales history. It recommends to use at least once just to see what it gives. Let's talk about a forecast error. Measuring forecast error is crucial to the forecasting process because it quantifies how far forecast deviates from actual outcomes, enabling businesses to identify inaccuracies, reduce bias, and improve forecast futures. Accurate measure, as with all data, helps manage risk, optimize inventory, and reduce overall costs from possibly over or under forecasting. Primary forecast tools include mean absolute deviation, MAD, root, mean squared, standard deviation, normal deviation, running some of the forecast error, and demand filters. The primary tool in calculating forecast error is the use of the normal distribution, or what we call the Poisson curve. Remember science. The measure of the incorrectness of the forecast is based on the mathematical concept of deviation, mean versus actual, or average versus actual. That is, standard deviation, or the mean absolute deviation of a population, or how far the occurrence is away from the average. The normal distribution has several uses. It can be applied to lots of natural phenomena: human weight, birth weight, blood pressure, suicides, earthquakes by region. Lots of applications of standard normal deviation. The mean absolute deviation measures average distance between each point and the mean of that data set. It quantifies variability by averaging the absolute deviations, making it sensitive to the directionality of the differences. MAD is the measure of wrongness of the forecast. The running sum of the forecast error is a cumulative metric that tracks the algebraic sum of the forecast deviations over time. It allows for detection of directional bias, for better inventory management, improves forecast, improves operational efficiency, and performance monitoring. A demand filter acts as a statistical quality control tool in manufacturing forecast, flagging exceptional deviations, typically set at plus or minus 4 mean absolute deviations. So companies can investigate and improve forecasting models and improve to more reliable supply chain and production planning. Tracking signals identify forecasts that become statistically biased. That is, if the tracking signal is less than 4 or greater than -4, it triggers a model recalibration. No matter what technique you're going to use, you must manage the raw data, and in most cases, enrich the raw data to make your forecast more viable. Demand or data management entails collecting and storing, organizing and category, ensuring data security, maintaining data quality, called prior period conformance. I remember my controller at Baxter Fenwal taught me that. Enable efficient data retrieval and analysis. Data enrichment entails verification, supplementation, and integration, where data cleansing allows you to clean the data and add relevant information, possibly comments, etc. Good data management provides the foundation for reliable, consistent, and accessible data. Forecasting in QAD starts with 22.7, simulation forecasting. You should learn how to use QAD's tools instead of spreadsheets. 22.7, forecasting starts with defining a simulation criteria, often referred to as a forecast ID. There's two types of forecasts, either an annual or a rolling. Forecast IDs identify the template of criteria based on statistical data, product information, and historical. The criteria template may be modified each time a calculation is performed. Here's an example of annual versus rolling forecast in QAD. This will have a significant effect on how you master schedule and how MRP recognizes that forecast. When using 22.7.1 simulation criteria, you set the years of history. Max is 5 years, and for ending, the field should be the same as or earlier than the forecast year. In 22.7.1, we set alpha to start usually at 0.3 and increase for volatility and decrease for stability. As to trend, the beta start at 0.2 and increase for stronger tens. Optimal approach is to use method 1, then validate with mean absolute deviation. Manual tuning is advised only when historical patterns are well understood. In 22.7.5, simulated forecast calculation, this generates a forecast for every item within the item range based on the history and forecast ID. The 22.7.5 simulated forecast calculation analyzes history to predict sales for a given year for the next 12 months. Remember, results are only as good as a sales order and criteria referenced. There are several ways to modify forecast criteria or forecast IDs. You can use 22.7.7 detailed forecast maintenance, or you can use 22.7.12 single item simulation copy, or 22.7.11 simulation to simulation copy, which replaces or combines forecast quantities. A few words about the simulated forecast. You cannot produce a rolling forecast manually. You can create or modify quantities in the detail record, 22.7.7. Forecast IDs provide forecast ID number, year, and item number, and you need to have quantities, 0 or not, for each month. The system creates corresponding criteria templates for each forecast, and manually created forecasts always use the forecast method of 0, 0. 22.7.7 detailed forecast maintenance is used to manually create or modify forecast results. You can enter quantities or adjust calculated quantities for each period. An original forecast of 0 indicates the system created the forecast manually. 22.7.9 detailed forecast reports allow you to display forecast quantities, cost, price, extended cost price, margins To display profit margins, both cost and price must be in the same currency. And if you use sim loads or QAD reporting format, you can create many more formats and reports. Copying or combining forecast results is a skill you will need to develop when you have to predict demand for a new product, or you want to combine or aggregate all the forecasts for an item, such as with multiple optional factors. With 22.7.11, simulation to simulation copy, you can combine the source and target simulation criteria with quantities or overwrite the targets with the source. The 22.7.12 single item simulation copy, you can copy one item per, where the source and the targets can be different. However, items must have identical units of measure and unit of measure or a unit of measure conversion. Multiplicity factors in QAD forecasting are used within and between forecast models, especially when you design to handle seasonality or external influences. You have your choice of replacing or combining, and in addition, you can manipulate base increase or decrease. You can scale the designation and the trend. This approach is particularly relevant in models where the impact of certain variables like seasonality and causal drivers is proportional to the overall level of demand. Be cautious when copying and combining forecast results. Remember, from a statistical point of view, the results of copying or combining is not a valid forecast. You should aggregate or combine historical data before doing forecast calculations, and multipliers should be applied to source quantity before replacing or adding to a target quantity. After you've created the simulated forecast, it's necessary then to copy that forecast idea to the summarized forecast that is used by MRP. There are three loading type methods that can be used to break down monthly quantities into weekly quantities used by MRP. Either one, an auto spread, where the monthly forecast is broken into daily averages and rolled into weekly buckets starting on Mondays. You can load last week, where monthly forecasts are loaded into the last week of the month, appearing on Monday. And you could use the load first week, where monthly forecasts are loaded in the first week of the month, appearing on Monday. The choice is yours. In 22.7.13, simulated to summarize forecast, the frame, you would select the site for uploading, select the loading method, and then select update to either create a report or send it to MRP. Seasonal build 22.9 allows users to enter and maintain schedules for building inventory ahead of anticipated seasonal spikes in demand. Once the forecast is complete, that is, the demand is recognized, forecast is created, both objective and subjective, is then input to 22.1 forecast maintenance. Forecast maintenance records the number of units of a particular item you expect to see demand for each period out across the horizon. In QAD, similar to SAP, Oracle, and other ERP systems, the concept of backward and forward consumption are central to how sales orders affect demand in MRP. These settings determine how actual sales consume forecasts, planned independent requirements, thus directly impacting inventory planning and procurement. This matrix will help you ascertain the positive and negative effects of either backward or forward consumption. Some experimentation may be necessary to understand the exact effect on MRP. Backward consumption is defined as a sales order will consume forecast before the sales order date. Forward consumption is defined as sales orders consuming forecast after the sales forecast. Again, the choice is yours. Forecasting plays a crucial role in MRP because it directly informs and shapes the entire planning process for production, inventory, and procurement. Forecast drives demand. It optimizes inventory, improves production scheduling, and supports customer satisfaction. As a point of reminder, there are primary inputs to MRP: BOM, quantity, and demand, which includes the master production schedule and forecast, in addition to shop orders, purchases. And note that the forecast demand is basically driving the entire process. Here is how QAD MRP Grid recognizes gross requirements, which include forecast requirements. You need to be able to read and understand how that's going to affect your projected quantity on hand and the planned orders that are generated from MRP. Learning forecast methodologies and how to manipulate the various methods require a fair amount of study, testing, and experimentation. To that end, 32Soft has developed a series of 3 data loaders that can make the process easier, and it is in a familiar Excel format. The first loader is the weekly version of 22/7. Consists of the selection criteria, buttons that allow for downloading, inquiring, setup, clearing, finding orders, and switching domains. And the column headings include the item, date, unit of measure, and monthly. As with all 32Soft loaders, the setup button defines the user ID, the password, and the domain. And when you have successfully uploaded the forecast, the system generates a message which indicates it has loaded successfully. Remember, if one error or one record errors out, no records will be loaded. The 22.1 loader loads MRP demand data, again, with the selection criteria, buttons, and various colors, which indicate changing values, editable fields, and the columns. The 22.1 month splits and loads values into a monthly period as input into the 22.1 forecast. Here you can see where the loader has split the quantity in a month between the various periods or weeks of forecast. Safety stock and forecast accuracy are closely linked in inventory. Safety stock is an extra inventory held to protect against uncertainties in demand and supply. In November, we're going to cover the calculation of safety stock and explain how to use this forecast loader. The 22.717 user forecast method maintenance allows additional new user-defined forecast method. This allows you to incorporate your own expertise into the system. Use this 22.717 forecast method. You must supply a progress program and a method number. There are some specific coding rules that are required. You want to review what is required for that. Just remember, you need to understand how progress works and create the appropriate rules. This is a list of the fields within your progress program that allow your self-defined forecast method to be used by MRP. There are a couple of forecast utilities that you might want to become familiar with: 22.25, 22.26, and 22.725.1. The 22.5 forecast recalculation provides a mean for the recalculation of a net forecast for MRP. The 22.26 ISO 8601 converts forecast records so it's compatible with that ISO 8601 definition for year start. And then the simulation criteria utility is a one-time update when you're upgrading from a version prior to EB to a EB2 and above. There's some limitations in the 22.7 simulation forecast. First, cannot use data other than the sales unless you go through the back door, such as sim loading. Cannot forecast configured products with standard forecasting. You can't forecast by sales. You can't convert a dollar value to sales. Remember, in the supply chain, we make things, we don't make dollars. And inflationary based currencies are not supported. Forecasting is vital for statistical planning, but it's fraught with obstacles. Understanding these challenges is a key to improving accuracy and business outcomes. You should use 22.723 detail forecast, delete and archive to delete and archive forecast records when online history is no longer needed. It can get a little messy. The QAD demand management user guide covers a QAD application that provides expanded demand management capabilities in QAD. The QAD demand management module lets you manage the needs of your company's products and services for a more robust process of projecting forecasts. The module includes managing users, scenarios, what are called living scenarios, how to use the engine manager, viewing forecasts, customizing viewers using filters and exceptions, using ABC and event managers, conversion factors, calendars, bombs. Here you can configure bills of material, use statistical forecasts, how to improve forecast accuracy, working with reports, grouping, allegation, life cycle forecasting, batch scheduler, and statistical methods. A very robust and complete forecasting tool. So as a summary, statistical forecasting enables organizations to make proactive, data-driven decisions. As the technology evolves, integrated advanced analytics and artificial intelligence, AI, will further advance forecasting accuracy and strategic value. Continuous improvement and ability are key to leveraging forecasts for a long time. Remember, you'll probably change the way you forecast as you get better. The forecasting has several principles to be aware of. First, forecasts are never right. They are always more accurate for product families or in the aggregate than detail. Forecasts are more accurate than near term than far term. Forecasts must include error estimates. You need to test forecasting methods. Forecasts are not a substitute for calculated demand. Don't forecast dependent demand. Forecasts need to be consumed by actual orders. We talked about the forward and backward consumption, and forecasts to be tracked and measured. The goal of forecasts is not to make them more right, it is to make them less wrong. So we've talked about what a forecast is, some business considerations, the process, techniques and methods, how to use forecast simulation, seasonal factors. We've looked at 32 soft forecast loaders, 22.1, consumption, a little bit about MRP, forecast users, and utilities. You already have one of the best ERP systems out there. Learn to use it. One of the big issues with MRP is the massive amount of data and logic that need to go into the data tables. 32 soft loaders can bring logic, accuracy, and consistency to your ERP planning process. The best approach to learning how to do forecasting is basically look at the online resources. There are courses out on the internet. There are books to read and certifications to acquire. QAD Forum provides a good place to collaborate and communicate with other QRD users. The QAD user groups, Midwest, West Coast, Southeast, have excellent discussion and resource boards, in addition to conferences and meetings. The QAD knowledge base, my place to go after F1, is an excellent way to look for tools on how to forecast. Artificial intelligence like ChatGPT, Claude, Copilot, and Perplexity is making this process amazingly simple. There is the QAD document library, everything you ever wanted to know about QAD, if you look hard enough. The learning recently renovated QAD Learning Center is a great place to learn more about QAD functionality. And as I had mentioned, here is a list of all of the URLs with clickable links for all the slides, documents, and records that were used for this presentation. And it's always good to learn how to use social media, artificial intelligence, to search information in this age of Aquarius. Here are 24 hashtags with respective URLs for subjects in forecasting in manufacturing. We hope you've enjoyed this quick tour through the QAD forecast tools and 32 soft loaders. The process of utilizing electronic tools is a challenge, and there is and are so many aspects of creating a viable ERP system. We hope you can take full advantage to learn the functionality. As I mentioned, you have one of the best ERPs out there available for your use. Proper understanding of forecasting and a good tool for executing that process can be critical to your success in today's competitive environment. Please contact Denise, Nancy, or Alex if you think you have any questions about ERP. And thank you so much. Denise, back to you.